Okay, we're looking at graphs, tables, and equations. For the most part, a lot of this will be review from what you've already covered, but I think there's maybe one step of the process we want to go through. Okay, so if we look at this, if I have to write an equation, well, we should know the y-intercept is 6. Okay, and I have a slope after I find my corners of -1 run 2, -1 run 2. So I have -1 over 2. So -1/2, and then my slope is -1/2, so I put x next to that. Okay, but now how do I make a table out of this? Couple of options. One option, easiest option of all, is to actually give some of these points. Like I see a point right there, or even right there. And by the way, I like my tables with 5 values. 5 values, okay? So let's go ahead. I got 5 red dots here. -4, +8. So I can write -4, +8. That's on my table, right? I could also go to this point. -2, +7. This point, 0, 6. This point, 2, 5. This point is 4, 4. Okay, that's one way to do it. Okay, I'm going to get rid of this. I'm going to show you another way. Oh no, I'm not going to get rid of that. I'm going to show you the alternative method. And we're going to use this y = 6 minus 1/2 x. Let's pretend we don't even have the graph. I can only go by this. Well, isn't 6 a y-intercept? That means 0 and 6 match. The reason why I put 0 here is because I like to use our fave 5 points. My fave 5 used to be a calling plan. It was like your fave 10 or your fave 5, I'm not sure. And so my fave 5 are -2, -1, 0, 1, and 2. Well, if 0 goes with 6, because that's the y-intercept, my slope is now -1/2. So if I go from 6 and I go down 1/2, or subtract 1/2 from that, wouldn't that be 5.5? And if I want to go down another 1/2 from that, that'd put me at 5. Okay, and if I go the other way, I go 6.5, 7. What's interesting about this is some of these points are the same. 0 goes with 6, same over here. And 2 goes with 5, which you also see over here. I just have some extra points over here and some extra points over here, but they're all on the same line. And I could put all kinds, there's lots of different points on this line. We just like to stick with the nice, pretty ones, really. Okay? All right, here's a table. What if I had to graph this? Well, I would graph the point -2, 10. And then I would graph the point -1, 13, 0, 16, and I'd make a line. Okay, I'm not even going to show you how to do that because you're so good at graphing. All right, so what we need to do now is write an equation. We've kind of done this before. Y equals, my y-intercept is my number across from 0, so 16, and my slope, okay, it's changing by 3's over here on the y column. On the x column, it's changing by 1's. And remember, it's change in y over change in x for my slope. So my slope would have to be 3 over 1, or I could just write 3x. If I want to graph y equals -x, we should be pros at this as well. -x means I have a y-intercept of 0. Change that to red. Y-intercept of 0 and a slope of -1 means rise -1, run 1, so on and so forth. Okay, I'm going to show you the table. One way, just to take the points that you've got there, graph -2, 2, -1, 1, 0, 0, 1, -1, or I can do my fave 5, because not all the time are you going to have a graph, or do you want to graph? So this means I put -2, okay, first of all, 0 goes across from my y-intercept, which is 1. Oh my gosh, silly me. That's not true. 0 goes across from 0. My slope is -1, so I'm going to go down by 1's. Here's another way. All these different ways to do the same thing. I could put negative 2 in place of x. What's negative? Negative 2. Positive 2. If I put negative 1 in for x, negative 1 is a positive 1. Put 0 in. Negative 0 really just comes out to be 0, and so on and so forth. I should do 2, negative 2. Okay, one too many ways probably on how to do that. We continue on. We want to make a table. Y equals negative x. Once again, we don't have the graph. We don't want to take the time. I think this was the one I just did. I'm going to keep going for it. I just did that, did I not? Yeah. Okay, one option. Let's start with our table. I see a corner here. And where's my next corner? Right here. My line isn't perfect. We're going to put our next corner there, it looks like. Okay, so it looks like I have a y-intercept. And I need to have 5 points, so I'm going to keep going. So I can have these 5 points listed out. And I'm going to get the coordinates of each one of them. 1, 2, 3, 4, 5, 6. So I have negative 6, negative 6. This to me looks like negative 3, negative 4. 0, negative 2. 3, 0. And it looks like I have 6, 2. Okay, double check, make sure you got a pattern. Negative 6, negative 3, 0, 3, 6. Negative 6, negative 4, negative 2, 0, 2. Looks good. Oh, if I write an equation for that, the y-intercept is negative 2. The slope is 2/3. Uh-oh. I have to write an equation for this. If I were to graph it, I'd have 2 points. That would probably get me started. But I want to write an equation for this. Remember what we do. We extend the table. Negative 8, negative 4, 0, 4. Negative 10, negative 12, negative 14, negative 16. So when I write my equation, my y-intercept is negative 14. And my change in my y column is subtracting 2 every time. My change in my x column is adding 4. And remember, it's change in y over change in x. The change in the y column is negative 2. The change in the x column is 4. Never leave a fraction unreduced in my class. So you're going to reduce it and write it in the equation. Minus 1/2 x. Graph, negative 2/3 x. Here's your y-intercept. Your slope would be negative 2/3. Negative 2/3. Okay, if you had to make a table, you would just use those points again. Or use your Fay 5. Let's say you don't have the graph. Here's another, well, this is the same way as before. If you don't have the graph, you can go ahead and say 0 matches with 0 and kind of go from there. Or I put 0 in here. What's 0 times negative 2/3? 0. I put 1. 1 times negative 2/3 is negative 2/3. 2 times negative 2/3 is negative 4/3. Continue the pattern. Negative 4/3, negative 2/3, 0, 2/3, 4/3. Okay, that might be tough to do. You might have to graph at your points. Or, yeah, I think this is probably about your best option for this. Make a table, I just did that. Okay, what if we don't count by ones? The x-axis, we're counting by 3s. So this is 3, 6, 9, 12, 15. And if I count by 5s here, I got 5, 10, 15, 20, 25, and 30. All right, you can kind of see how this is going. I'm going to find some corners here. It looks to me like I have a y-intercept of 0, so I have y equals 0. And I rise, and here's the thing, I'm not rising 1. I'm rising negative 5. Because every one of these represents 5 units. And I'm running 3. Rising negative 5, running 3. So I'm rising negative 5, running 3, and that's my slope. Craziness. Once again, y-intercept of 0. My slope looks to be going down by 10s. My x-axis seems to be counting up by 10s. So now I've got negative 10 over 10, which is negative 1 for a slope. So I have 0 plus negative 1x, or if you're really sneaky, you can just write negative x. Just maybe one more here. Graph y equals negative 5. We should be good with that. Okay, we have a y-intercept of negative 5, a slope of 0. If you were to make a table, your y value is always negative 5, no matter what. Look at this, 2, negative 5, 3, negative 5. So no matter what I write, my y column will be negative 5s. And I can put whatever I want in for x. And if you wanted to put negative 72, negative 15, that's fine. I would prefer to say 5. We just stick with simple numbers. Okay, we just made a table for that. We got to go through this just because it's a special case. Let's see. What does the table look like? Here's a point. It's 1, 0. Here's a point. It's 1, 1. Here's a point. 1, 2. Here's a point. 1, 3. Here's a point. I like to have some negatives in there. 1, negative 1. Here's another point. 1, negative 2. No matter what, my x value is always 1. So x equals 1. All right, and I think that is plenty to get that topic under control.